Hello. So good morning, everybody. Can you please confirm if you can hear me?
Good morning, sir. Yes.
All right. So let's begin our discussions for today. Before I begin our discussions, guys, are there any doubts from the previous lecture? Anything that we covered in the last any of the last lectures? Is it something that you have any questions? You have any doubts from there? All right. If there are no doubts, then let's begin. All right. So, guys, so far, everyone can see my screen, right? Everyone can see my screen, right? Can I get some good thumbs up? Yes, no?
Yes.
Okay. All right. Yes. Thank you. So, guys, so far, what we discussed is more about infrastructure as a service. In the today's class, I'm going to introduce you guys with a platform as a service. So, basically, these are the two service models that we have. Okay. So for the last three sessions or so, we saw quite in details about infrastructure as a service, and we saw various services of AWS as well as from Azure in order to understand infrastructure as a service in a much better manner, which ultimately forms the basis of the two other service models that we are going to talk about. It formulates the foundations or the building blocks for the other two service models, which we are going to discuss today, which is platform as a service and software as a service. So let's get started on this. Now I'm sure that all of you would recall over this particular picture. This basically gives you the differences between the various service models along with in comparison with various on-premises models. In the case of on-premises, basically, you need not, you basically, you're owning everything, right? You need to own everything. You basically stand for the customer. Okay, he has to manage. He as a customer has to manage everything. He needs to own. He has to patch the operating system. He has to install the operating system. He has to perform the setup of the networking. He has to create the VLANs, subnets. So whatever is the case, it is the owner's responsibility. Then we looked into the aspect of infrastructure as a service. And now we are discussing about the platform as a service. All the blue blocks, guys, which are there in the column, that is the platform as a service, starting from the network, storage, and server, contributes to the elements which are responsibility of the cloud service provider. On the top of it, we have virtualization layer, which forms the infrastructure as a service. That comes internally, and along with that, there are two more layers which are added. For example, operating system layer and middleware layer. This middleware could be basically what we are intending to say is that the development environment. Okay, the development environment which consists of various tools, softwares, which are required for anybody to use this particular piece as a platform in order to develop their applications. So on the top of that, whatever the applications in the data part which is there, that is the owner's responsibility. Owner's responsibility in the sense that when I say data, storage is coming from the platform, that is the platform as a service. But how do you need to store the data? What format you need to store the data into? What is the structure? What is the schema going to be which needs to be followed? What needs to be done with this application? Right? How it needs to be to go in the development phase or operation phase or staging, testing phase, etc. All those various aspects which consist of these two layers, that is application and the data, is all the responsibility of the owner. Okay. So having understood with respect to the various layers, that dependency between the infrastructure as a service and platform as a service, right? We understand that there are many components in the platform as a service as well, many means application the data, which are still the responsibility of the owner, the customer, in contrast to the less responsibility that the customers in contrast to the more responsibility that the customers has in the case of the infrastructure as a service, and in contrast to the less responsibility that the customers has in the case of the software as a service. So platform as a service is basically one of the service model which came in after the infrastructure as a service. So the world initially started with the all infrastructure as a service as its primary opening to the world through IaaS. Later Microsoft and they also pitched themselves as a player in the platform as a service field. So Microsoft said that whenever whatever environment it provides, it basically would help the developer community, and it also promised that it would give you the platform with the help of which you can develop your applications and go to the various stages of integration, whether it's either the database or either the middlewares or the queues. So whatever was required, these integrations were provided. These endpoints were provided which were consumed or used by these applications. Okay. So try to pitch in that service models. Of course, over the period of the time, it also changed its ways, and it said that it caters to everything. That is, it does not purely caters to platform as a service, but it also even caters to infrastructure as a service. Even AWS has moved from its primary offerings of infrastructure as a service to the other service models, which could be platform as a service or the software as a service. Now, what does this platform as a service allows any users to do? It helps to create softwares which are hosted on the cloud, and these softwares would be obviously used by the end users over the internet using a simpler web browser. Now consider yourself as a developer who is working for a customer relationship management software. So basically what shall happen is you would have to develop this particular software. In order to develop this software, you have to set up this development environment. Okay. After setting up this development environment, then you have to make use of various tools and resources which are there in order to develop the application. That shall be the traditional way of developing the applications. But here, what would happen? There could be various pieces which basically you need your attention in the terms of the configuration, as in how do you connect to the databases, how do you connect to the middleware, how do you set up the certain things which are required. Okay, it requires a good amount of configuration, my dear friends. So here the things does not come ready made as a platform for you. So you as a developer, you as a uh, you know executor, or like this system owner, need to look into the various aspects. Of course, you would also involve the system administrator in order to set up the various things on your system, in order to help you to set up on your system, in order to help you set up the development environment, and the stuff like that. In the platform as a service, none of these have to be looked in for. What is that they will have to go for? To subscribe to a specific pre-configured environment, which will give the facility for them to go ahead and target on what they are supposed to do. Their aim is to work on the application, optimize the application, and improve the application, right? So they shall look into all those aspects. I mean, that is the core strength of the developer, isn't it? They will concentrate on the development instead of concentrating on the all other configurations. So who is doing all of this? The vendor is taking care of all of these things, and depending upon what is your requirement, the cloud service provider is going to provide the offering to you. Examples of the platform as a service are, for example, if you have you ever heard about AWS Elastic Beanstalk, right? From the Google, we have been hearing about Google App Engine. How many of you have worked upon the Google App Engine or AWS Beanstalk? Just put in the chat window. Okay, nobody have worked, no problem. From Azure, we have Azure SQL database, Cosmos DB, the one that we discussed right last class. That is also comes under the platform as a service. We also uh, discussed a very bit about Azure Functions, Azure Logic Apps, or Kubernetes service, Azure Kubernetes service, right, in our previous lectures. That is also platform as a service, my dear students. Why? Because here the Microsoft is maintaining the operating system. When you spinned up the Cosmos DB, then we didn't have to bother about operating system, middleware, and updates, right? We as a developer were focused on the application logic, not on the infrastructure. They provided a built-in monitoring, deployment, SDK support, right? Everything is being provided out of the box. So we pay only for what you use, like the compute time, DB operations, which was in the form of RUs, right? I hope all of you are getting clear with what I'm talking about. All right. So I would like to now go much deeper now, guys. I would like to just, by the way, place a cautionary note over here. That is, you may find quite a lot of things would get repeated in all of the slides. So, repeated in the sense that certain things from the infrastructure as a service might get repeated in the platform as a service, and certain things from the platform as a service might get repeated into the future slide of platform as a service, and a similar case with the software as a service. It has various perspectives to discuss. So don't bother yourself, okay, thinking why I am repeating the same thing again and again and again. Otherwise, it gets over in just some 2-3 slides. But each of this particular slide would try to add certain value to what you all know and what all that we have already discussed already. So this is something we have kind of understood, that when it comes to platform as a service offering, the major chunk of the stack which we are looking at, which supports storage, network access, hosting, operating system, various middlewares, which are all required, right? All of these things, my dear students, comes in as a package together, so that the developer can work on their original ideas to create the application. Okay? So they will create the application. They shall go through the testing phase. They shall go through the deployment phase, and in the end, what you have is a good application which is developed, and this application is easy to market as well as developed in a better way, in a better environment than what it used to be in the workplace. Why is it better? Because whatever the environment which you create, it does not have to get restricted only for the developer community. The same environment with the required tools can get provisioned, right, with their set of required tools in order to test this particular application. Similarly, the same thing can go for delivery as well as for the deployment. Okay, that's the beauty of this cloud infrastructure, which provides a service model in the form of platform as a service. A developer is going to get a development environment. A tester or a quality assurance team is going to get a testing environment. Similarly, there could be delivery deployment stages as well, which would require their own environment, and these things shall be seamlessly provided to the respective community so that they can work on the details of the application which is going to get developed and deployed. Okay. So what are the benefits of the platform as a service? It helps in the us to take our products faster to the market. Faster time to the market means make your application available to the market in the faster time. What does it mean? Here what we have to understand is that for the organizations, there is no need to purchase or install the hardware or software which is required. Okay. So you require the hardware, you require the software which you need to purchase. In order to purchase, you need to go for various approval processes. Of course, in case of the platform as a service as well, we still require the process, but that is little easy and transparent with respect to the subscriptions that we take, rather than going through the various details of what kind of hardware that needs to be purchased, what kind of software that needs to be purchased, who is going to build it, who is going to maintain it, who is going to set up the application environment on the top of it. So all these things, all of these various peripheral things are almost equal to zero. Why? Because of which we can utilize our time on the development and optimization of the code, making our application more efficient. They become zero because of the platform as a service. And whatever time we save out of it, we can use it for the other optimizations, development, efficient, to just improve the efficiency. That's the reason we say that this helps applications to reach the market much faster compared to the traditional base. The next one, you get wider variety of the resources to work upon. So what is that? You get wider range of choices in the application stack, which could include like the various middleware, operating system, databases, various other tools. So if you want to try out the Linux based or any flavor of the Linux based, you can pick and choose from it. or if you want to choose the different type of the messaging queues rather than the RabbitMQ, then there are other notification services which are available, and with them you can go ahead. Likewise, the case for the database. Okay, there is a good range of choices for you to pick up from. Okay, of course, internally you would have to deliberate on what kind of stacks you have to go with. But here in the case of the platform as a service, they are already placed on the table. You just have to pick them up, and rest of it is getting configured in no time. You can get to use the platform as very quickly. Okay, and the third point it talks about is freedom to experiment. What is this freedom to experiment? Now, I'm sure most of you would have experienced having applications which were built on Python 2, then Python 3 came, which was a big change from Python 2, isn't it? But applications did move from Python 2 to Python 3 because it has a good set of features that made the application to work better. But it was an automatic movement. No, there were a lot of experiments which were actually done. Okay, so it was proved that yes, Python 3 could basically benefit most of these applications, because of which they moved. Now Golang seems to be the go-to language for the development as such. Okay, if somebody wants to try out that, now again, what is that they have to do? If at all you are setting up everything, you have to set up the entire stack and see that how the things work. But if you try and take the service which is platform as a service, it is already pretty much set up by the experts, and you have to just use the environment to test and see how does your application performs using the new set of tools or languages with which you are actually going to build it. So it gives you the option to try out the new language, operating system, and other tools without having to making any substantial investment on the infrastructure as such, isn't it? You can pick and choose, try, and you do not have to invest too much also. So whatever basically we know for the fact that cloud is as a pay as you go model. So whatever you have used, you would have to pay for that. You don't have to buy the hardware. You don't have to buy the license for any software. Nothing of that sort. And that leads us to easy and cost-effective scalability. What is that scalability that we are talking about here? Basically, if we have to understand the cost-effective scalability, we shall have to understand what shall happen if the things works on premises. How does the scaling happens on premises? Can anybody tell me? Can anybody explain how does the scaling happen on premises?
We need we need to buy for the scaling up. We need to buy new servers, set up the operating systems, required softwares, and everything. That's in case of scaling down, we need to decommission the old servers.
Very nice. Anybody else who would like to add?
Additional licenses for OS or licensed softwares when scaling up and down, like releasing the licenses and buying back.
Very good. Anyone else who would like to contribute? So, guys, if I'm using the platform on premises, then scaling is quite costly. How? As you all just had mentioned, certain times it could even be wasteful, right? Or it could be inadequate, because we anticipate a certain spikes based upon which I would have to go ahead and procure the platform, the hardware. software and set up the whole infrastructure as well as build the platform. But is it used all the times? No. Whenever there is a low traffic, the systems would end up like being idle. Okay, so on-premise scalability is a very costly affair. Compared to that, when we move to the platform as a service kind of solution, it is a very cost-effective scalability because we know for a fact that scalability is an inherent feature of any cloud offering. And it also gives you the shared software development environment, which allows the teams to come together. That is both the development team, operations team, and the testing team to come together in order to access these various tools which are there from any location. Now, it is not required for you to have all your teams placed in one particular location. Depending upon their availability, they can be placed in any part of the world as such. And you can basically see that your team seamlessly uses the platform in order to either develop or test or look at the operations of this application. Okay. So considering all these things, finally, we can definitely say that it reduces the overall costing. Okay. What is this overall cost? First, it avoids any capital cost. That is, there is no capex, that is capital expenditure. I'm not buying any hardware. I'm not buying any software. I'm not setting up. I'm not hiring in order to set up anything. There are no licensing costs where basically you tend to buy the license for certain software. There is no patching. There is no maintenance. Basically nothing. And all I have to do is pay to the cloud vendor who is providing me the services. So these are the overall benefits that we have for the platform as a service model. Any doubts that anyone have, please ask. All right. Finally, we have understood the benefits of the platform as a service. But how does it works? Generally, what we see is that platform as a service had got three important parts. We have seen the first part. In the very first diagram, where it says that until the data, all other layers are provided by the cloud vendor. That is cloud infrastructure, which help involve the virtual machine, what kind of operating system goes into, what kind of storage needs to be used, whether it is object storage that you wanted to use, or whether it is unstructured storage or block storage that you wanted to talk to. All those things are on one side, are one side of the things, which gives the infrastructure on which you are going to develop the application. That is one part of it. Secondly, you need to have the platform as such. Okay. The software, the IDE which integrates. You can have your own IDE and you have your integration with the various languages or environments, the deploying environments and the testing environments. This is another part which is there, which shall help you to develop the application. And finally, you can have the graphical user interface, which will help you to develop or test or DevOps your applications. Yeah. So throughout the entire application lifecycle, this GUI is the only one with which you have to interact. Whether you are a developer, you are a tester, or a deployer, or a delivery person as such, these are the very three important parts of the platform as a service solution. So now let's moving on. What are the various use cases of the platform as a service? So guys, we have understood the benefits of the platform as a service. We have seen that how platform as a service works. What are these various use cases in which we can go ahead and use the platform as a service? One is of course the API development and management. I'm sure most of you would understand what is an API. This stands for Application Programming Interface. And I'm sure you also know the use of the API, the what it is being used for. It is used to share the data or functionality between applications, isn't it? We make API calls, whether to share the data or functionality between the various applications which are there. Okay. Now this platform as a service, it makes development of the API quite easy. Why? Because it has a built-in framework, which is much simpler for the teams to develop, run, manage the application. That is, the API is in a secure manner. As I said, the development environment, the testing environment, it is all coming from the same source. So you develop your application, that is the API, then you can even test it. All of these things can be done in a secure way as well. Next, coming to the IoT, that is Internet of the Things. I'm sure most of you are aware of it. Internet of the Things says that now you are not only one just working with the applications or the softwares, but you are basically talking to the things. What are those things? Things like you have your refrigerator, you have your TV, your fan, tube light. And what is expected, basically what is expected here is that you are interacting to the very last commodity which is there, which is a part of this particular line that is a physical world. What makes the physical world? The temperature makes the physical world. The pressure makes the physical world. Various objects which makes the physical world. Okay, now all of them are connected over this huge network, which is this internet. Therefore, the platform as a service can help us to support for the development of the IoT. How? Platform as a service is helpful over here because it supports a wide range of programming language models, a good amount of tools and different environments. You want to work upon the LAMP technology? There is a provision for that. So for those who do not know, LAMP is Linux, Apache, MySQL, and PHP. So you have to work upon the mean stack. There is a provision for that. Basically, mean is an end-to-end JavaScript stack which consists of Mongo, Express, Angular, and Node.js technologies. And the reason that I mentioned all of this to you is it provides various environments using which I can develop my applications, which can be further used for IoT. And it can also help me in the real-time processing of the data. Real-time processing is a very obvious thing when it comes to the Internet of the Things, because all of these devices, they send the data on a continuous basis. Okay. So it could be some live feed, or it could be some temperature sensing, or it could be some pressure sensing, or it could be some sensing which might be attached to a patient. Okay. So all of this are the continuous in the nature. So this environment, it could possibly help us in the real-time processing, right? Now moving on to the third one, my dear friends. Agile development in DevOps. What the platform as a service provides is a fully configured environment. Okay. What is this fully configured environment? A fully configured environment is the one which supports development, testing, staging, deployment, and delivery. And in all of this, basically, you can automate the whole software lifecycle. That is integration paths, delivery paths, security, testing, and deployment. All of these steps can be automated, and the whole software lifecycle can actually be managed. And the next one here is cloud migration and cloud native development. So PaaS tools and platforms, it definitely helps us to simplify the migration of your existing applications to the cloud. Okay, so these, we have it in the two forms. Either we call it as replatforming or refactoring. Replatforming, what it says is that whatever the existing platform that you are into, now you are moving on to a cloud platform with the modifications. Why do you need modifications? Because this modification should help the application take the advantages of the cloud. Now, what is the point in you deploying the application to your cloud, which was on your on-premises servers? It was always suffering from load balancer, or it was not able to scale properly because it was not built for the cloud kind of environment. So if you try and take it and put it as like in any of the server, then it is still not going to help you. Only the virtual machines get scaled, isn't it? This is not enough. Your code should also be able to scale accordingly, in a sense that depending upon the load, you should be able to handle more load. You should be, depending upon the load, you should be able to maintain the connection pools. You should be able to make connection to the databases as and when required. Basically, your code should also be able to participate. That's what I'm trying to say here. Okay. With modifications, the application shall move to the cloud in order to take the better advantage of the cloud scalability or load balancing or security features which are there into the cloud. So this is termed as replatforming. The other one, my dear friends, is refactoring. Refactoring, so you have your application and you would like to refactor its architecture so that now from monolithic architecture or to the modular architecture to the microservices based architecture, or it could be a combination of modular with microservices based architecture. Okay. Now, when we talk about the microservices, containers are the compute units for it. Okay. So microservices with the containers and other cloud native technology could actually be used in order for the development. So it really makes all of these things quite easier. Last one is hybrid cloud strategy. What is this hybrid cloud strategy? So you can have a combination of public, private, and on-premises cloud, which basically provides a uniformed, flexible, distributed environment, which consists of computing environment on which you are going to develop your applications and deploy your applications. So these are various use cases of platform as a service. Now there are certain purpose-built platform as a service types also. What is this purpose-built platform as a service types? Now there are certain platforms which are built for the certain domains. By domains here we are not talking about various domains as in the industry. Rather here we are talking about the application domains. That is the platform as a service for artificial intelligence, which is AI PaaS. Okay. So here, as the name itself says, you have your platform in order to build your AI applications. What is so very different from other applications? Basically, when we talk about the AI applications or deep learning applications or NLP applications, they are very compute intensive and they require a huge amount of storage because they would have to work on huge data sets as such, because of which you would require your environment to work with all of these dynamics. Okay, so these AI platform as a service basically provides a platform for you to work on the AI applications. Okay, then you have iPaaS, which is basically integration platform as a service. These are cloud hosted solutions for integration applications. Then you have CPaaS, which is for communication. This stands for communication platform as a service. How are these useful, by the way? So there is a telecom provider, for example, like Jio or maybe Airtel. What it provides is something like this. So you have your application built in, but you would want to put it in a feature of voice call or video call or messaging. That's where it provides the endpoints which are all landing into the cloud, which would be used by the developer in a very, very easy manner and integrate all of these things and bringing these capabilities to an application. And we do not have to really spend our time looking for the various details of what kind of real-time service protocol needs to be used, what kind of other software and hardware is required, what kind of other middleware is required. We don't have to really bother about all of those things. We just consume those endpoints which are there, the APIs which are provided, the platform APIs which are provided, which are internally internally could take care of either voice-based or video-based or messaging platforms, communication as such. Finally, the last one, it simplifies the application development on mobile devices. So this is mobile platform as a service by integrating various other services. It could be location-based services, or it could be notification-based service, or it could be CPaaS participate over here. So that's where the platform as a service stands. So I hope, my dear students, that the things are becoming clear when it comes to platform as a service. I'd like to take a quick pause to check if you have any questions, any doubts so far. Please raise your hands or speak up.
Sir, can you please explain once again the cloud strategy in the context of PaaS? Hybrid cloud strategy.
Sure. So see, what we basically say is, so one thing is clear, right? The hybrid cloud that we explained is clear, right? It combines on-premises infrastructure as well as the public cloud services, correct? Like for example, any public cloud service which is from Azure, AWS or Google. Now, hybrid cloud, if we talk in the context of PaaS, normally the platform as a services, like for example, Cosmos DB, Azure SQL DB, App Service, they all run in the public cloud, correct? But hybrid strategy allows you to extend or connect the platform as a service capabilities to its own premises or edge environments. So you're running the modern PaaS applications anywhere on Azure or your own data center while using a single control plane. So what are the services that can enable the hybrid platform as a service? For example, if you have worked upon Azure Arc, right? So Azure Arc is a service which would enable or extend Azure services like the PostgreSQL, Azure SQL, etc. to on-premises or to multi-cloud. Right? So similarly, Azure App Service is the one which deploys the platform as a service applications in your virtual network, providing the network as a solution. So that's what we basically meant here, that in the context of, one company which is using the hybrid cloud strategy, how can we have the platform as a service offerings be available on their on-premises infrastructure? That is what we talked about here. Is it clear, or should I give one more example? Okay, let's take another example. So consider, guys, like there is a smart factory. Okay, there is a smart manufacturing company. They want to modernize their production line. So they have their machines, right, which are on premises. For example, like consider like the Tata Motors, or consider like Tata Steel. So they have their machines which are on premises. And of course, they also have the analytics and dashboards which they have created in maybe any of the cloud platform, like Azure, say. So now they have their factory floor. On their factory floor, they would have their machines, which would have, from where we would have to collect the data locally from the IoT sensors. That's where we can use Azure Stack, right? There's a Azure Stack Edge that we can use there. And we have Azure IoT Hub, which we can connect devices to the cloud. Of course, there are the same offerings in the AWS and the Google also, but I'm talking just to give you an example. So the benefit of the Azure Stack Edge is, even if the factory is not using the internet, Azure Stack Edge would continue processing locally, and it would sync up with Azure whenever it would get the online connectivity. That is about the hybrid pass. Is it clear or not?
Yes, sir, it is clear.
Thank you. Anybody else? Any other question? Any other? Please ask. Don't hesitate, guys. Wherever your doubts are, please clear.
So I have one more doubt. So, for example, when we are adopting to use the PaaS service model, so in such scenarios, my application is developed in the .NET. So, is there is any compatibility issues between the application programming language which we used and the infrastructure we have utilized through the PaaS?
Good question. So your question is, you're using .NET. So can there be the compatibility issues, right?
Yes.
See, the first thing that you have to understand is that what I mentioned in the earlier slide, in the platform as a service, as a developer, you are responsible only for the two things, right? For example, you're only responsible for developing the code and managing the code. Remember this particular slide that I talked about, application and their data, correct? Now, of course, say suppose your application was built and developed earlier into the .NET, say suppose some 4.x framework, right? So now, when you move your .NET application to the Azure platform as a service, or maybe to AWS platform as a service, whatever, like, okay, then sometimes some of the platform as a services may not support all the features. Okay. In that case, you might have to do a refactoring of your application. I'm talking about the older versions, guys. Okay, please don't confuse. But if you're using, for example, like the new latest versions of the .NET, imagine that you're using .NET 6 plus version, then I think that is fully supported on the platform as a service. I'm sure there would be issues with the older models, older frameworks. But with a newer version, there would be minimal issues. There would be little bit of issue, there would be minimal issues. What can be the issues? For example, there can be issues with respect to the connections, strings, etc., file system path, right? Or some configuration related kind of stuff. Okay. Now I will give you one practical example from my experience of working. So guys, one of the long time back, I was having one of my applications which was having uh, basically that time we used sessions in the memory. So our application we had to move to the cloud, and we adopted the platform as a service. That time we realized that platform as a services are basically stateless in nature. Their instances can scale up, scale down anytime. So having a session in the memory would lead to the problems, because there is no guarantee that this application is going to run, because the instance can scale up down anytime. So in that case, you would have to definitely move your sessions to the Azure cache, or maybe to the Redis, onto the AWS cloud. And we had to do that kind of change because our application was the stateful application, whereas the platform as a service services are usually by design stateless in the nature. Okay. Is it clear?
Yes, sir.
Okay. Any other question? Please ask. All right. So there are no further doubts. Let's proceed further, guys. Now let's move our attention, guys, to the software as a service. So, guys, here also I would like to put a cautionary note that there are a good amount of interesting things that may you seem to be repeating. Okay. So we will start with this particular picture, which is again you have already seen earlier. We are now not looking for the stack for the past, but rather we are now looking at the stack for the SaaS, which is this last leg of our talking. So SaaS is the simplest of it when it comes to the usage purpose, but underneath there are a lot of things that we would have to understand. Okay, here is what is happening. I just have to subscribe to this particular software usage. How are you going to use it? So I have a simple browser installed on our system, then I can use it. What is the problem with the earlier one? I would like to take a couple of instances. Earlier, back when we used to use the Microsoft Outlook, the very first thing that everybody does in the morning is to check the emails and look into the inbox. At that time, heavy Outlook was there basically, was people was heavily using that Outlook on their machines, which we opened up and checked for the incoming messages. This Outlook actually talks to the server in order to refresh your inbox. Okay. Many a times you guys might also have experienced that the Outlook would be stuck and would not open at all. And we shall end up seeing a message that server is not responding. Why is the server not responding? Because the server is stuck with huge number of messages in the queue. The server is not able to handle those messages because it does not have that necessary hardware resources to handle it. That is, it does not have the compute resources or storage resources or RAM for that matter to handle the incoming messages. Why? Because same server is being used to host the certain other applications as well. So it really did not help. We usually had to wait till the system admin comes in and he understands the problem immediately, and then he does something or other thing, probably restart, and things will start working, which definitely is not a pleasant scenario for all of us. Of course, it does not happen most of the times in the big companies as such, but even small companies are also the customers and they also participate in this ecosystem. So there were these difficulties which were faced by the small companies as such. Why? Because they had to set up the environments on their own. Okay. A mail server had to be installed on their own. Of course, there were multiple types of mail servers as such. What we had was an open source mail server. Okay, open source mail server is of course free as such. We does not need to pay for the licensing for the same. Whatever upgrades are there, they shall happen and they would take their own time. If I really want this open source software to work well, then I need to have a team dedicated which shall maintain this software, isn't it? Okay. Or the another option is that I would have to go and buy the license for a very good software, which can be quite costly in the nature. So that's where it used to stand. These licenses, which were not the daily or the weekly licenses, but these are usually year-on-year licenses, and we have to usually renew the license every year. If the license is not renewed, then the whole work would come to standstill. So these are the various problems which we encountered by having our own software. So what does the SaaS do? So I love the very first version of the Gmail, guys. It was a very plain interface as such, absolutely no fancy stuff, nothing. Even its search was not that great. It used to load slowly. Nowadays, all of us we have a broadband connection, and and the interface can load very quickly. In the pro in the broadband in the before pre-broadband days, the Gmail version took a lot of time to even load, and forget about the search also. It started along with Yahoo and Rediff as a mail service. Providers, they all provided free, of course, but then the Gmail has now come a very long way. Now it is open for the businesses as well as for that email matter. We all together are the customers of this particular software as a service, which is Gmail. Just imagine that you have your servers installed, which supports almost 30,000 users. I mean, I'm not talking about a company, I'm talking about an academic institution like ours, which has to maintain the mail server just in order to accommodate only the will students. And then on the top of that, there are 10,000s of alumni who have already passed out. For you people, after the 4 semesters are done, whatever is your WILP email ID would be automatically converted into alumni email ID. Just imagine how much of the effort it shall take for all of us. If the same has to be maintained by the personnel of the BITS Pilani, how many people would be required in order to look into the details as such? Okay. If we are setting up our own ERP, anyways, our ERP right now is not on the cloud, maintained on the Pilani servers, we get into various difficulties because of that. In short, what is SaaS? It is a software distribution model. Okay. Application itself is being hosted by the cloud service provider or the vendor, whatever you say to that. Okay. How will you access this application? This is done typically over a network which is over the internet. And traditionally, what used to happen is that we shall have to purchase the software, then it has to be installed on one particular machine, and consider this machine to be high grade server. So generally, high grade is what, like at least 32 GB RAM, 6 or maybe 64 GB RAM, that it used to be the high end server. Then you have your clients that needs to be installed on your personal computers. Okay. So we have already discussed about the problems for the traditional model. The first one is the licensing costs. Who has to manage the software? It is the owner who has to manage the software. It requires to purchase the license, which has the high upfront cost, and finally also have the ongoing maintenance cost. What is ROI? Return on investment? It is delayed considerably because initially the upfront cost is high because we have to spend a good amount of money for the setup. You have to first develop the application and market this application, and then you have to launch to the market, and then you would be able to recover all of those money which you have spent. Okay. These were the times when before you develop an application, you see the market for that product has already gone. It has already become obsolete. Those cases we have also seen, right? This picture kind of depicts that. So what is the traditional software tools? Like for example, this is a nuclear plant. So in case you want your energy, you build the whole setup at your own. And this is synonymous towards scenario while talking especially in the traditional world. Whereas on the right hand side of the screen, you have the own demand utility. I don't require to set up everything on my own. I just want to use electricity as such. So what do? I have these plugs which I use to plug in, subscribe and pay for what I use. Okay. So how is this SaaS delivered? SaaS, we know for a fact that it is delivered using the browser, which is over the web. Okay, so you need to have this internet using which you get access to the software as a service application. And generally, these software as a service applications are built in with something like one-to-many models. One-to-many means you have a single instance of the application running, but multiple users using this particular instance. In the traditional world, what used to happen? It mostly used to happen one-to-one model as such. So architecture-wise, how is it placed? Now it is run by the internet technologies. If we have to compare the cost of a PC to the cost of an application, the cost of PC has definitely come down these days. If we want to purchase a PC these days, I can have it in a minimum of 12 to 15,000, I think so. But it definitely, I'm talking about it, desktop PC guys, don't get confused. But application cost reduction has not yet happened in that manner as such. If I have to set up the certain things, it still cost me like a very big bomb. In order to set it up, effort, stands, expensive, right? Of course, it also involves the licensing issues which might be there and they need to be distributed. Now, given to this day, there are many very real heavy applications as well which cannot be moved to the cloud. Just imagine if you had to run the same software on your machines. Let's talk about. I'm talking about a software like Solid Edge. Mostly all of this software scatters to the aeronautical industry, in which simulators which are being used, mechanical industry or automobile industry. All of these softwares, if I have to run these softwares in laptop or in desktop or something, then I need to have a machine which is at least 32 GB of the RAM and 4 to 8 cores of the minimal requirement. Of course, we do not We do have all of these softwares which are used by our core engineering students. But now with the cloud era, we do not have to go for that headache because these are all hosted in the cloud. Whatever resources demand is there, it is all happening over there. Okay. We can see the end results to it in a very easy manner once we have configured the softwares to be run into the cloud. Right. So these are some of the benefits or the architectural benefits, I would say, which would help us students. Now, when it comes to the application architecture, there are three things which stands out. The first one is scalable, then multi-tenant, and the third one is a configuration. So scaling of the application, basically what it is trying to say is that we have to maximize the concurrency. Okay, what does it mean? In the sense that when you deploy your application, whatever the resources which are there, they are coming from the shared pool of resources. Your application must be hosting as a set of threads or network connections or the data which is actually cached. Okay, so all these things again get shared. Even databases for that matter, you do not have to pay, you don't have to have separate databases. It could be database which can get scaled or get partitioned from very large databases. Coming to the next one, which is multi-tenancy. As I said earlier, you have a single instance of your application which is running, but multiple tenants are using it. A classical example could be the Dropbox example, or it could be Salesforce, or it could be G Suite as such, which we have. There are hundreds and hundreds of thousands of educational institutes or the companies which are making use of the G Suite. Isn't it? It's a single instance which is running actually, but internally what is happening? The applications are also using the same databases, but there is a secure partitioning between the data which gets stored in this particular database. Okay. So whatever the end users are using is the same. I mean, same set of functionality used by all set of users. Of course, they can modularize or they can subscribe to the modules. Otherwise, it is the same set of functionalities which comes to the set of users. Configurable. So here we are talking about a single instance application, my dear students. Does it mean that I cannot configure for my needs? It's possible. Okay, so using the metadata, each of the customers can configure their applications. It could be the way it appears or it could be the way it behaves with the end users. So I as an end education institute might want to have certain set of features for my own organization. For example, easiest thing is I want to have my own logo. It is not going to change the base instance, which is actually running, right? These are all the cosmetic changes which can be done with the help of metadata configuration, which is being provided by the one set of users. And for all of these things, it does not require any extra development cost. You just have to go to configuration page and say that these are all the things which needs to be configured for my instance. Now SaaS models, software delivery model, traditionally they were on premises, whereas the SaaS delivery model is in the cloud. The traditional delivery model, it is mostly centralized, and SaaS delivery model is mostly decentralized. The traditional delivery model has large upfront cost, and SaaS delivery model is mostly decentralized, based upon the pay-as-you-go model. business model for application hosting requires perpetual licenses, whereas the SaaS is mostly subscription based. Many times, even free subscriptions are also given so that it could be tried and tested before it can be used. Okay, application hosting, for example, it's one to few, whereas SaaS is one to many. Application hosting from the infrastructure point of view is a private, whereas in the case of the SaaS, it is a shared public infrastructure, isn't it? So I will discuss the business model, but before that, is there any question, guys? Tell me.
Sir, I have one. Um, in case of multi-tenant, right? So for segregating the data, maybe the software running the instance may be same, or scaling is also part of that. But the data for multi-tenants, are we having different database for each tenant behind the scene?
Mhm. So when you say different databases, you mean different instances or what?
My question is, I mean, I want to know how the data segregates in case of multi-tenant. I mean, one company data, how it's segregated from another company. Is it a software driven or the database itself is different for
Hmm.
each tenant?
So say in case of the Gmail, right?
Yeah.
I think this is an excellent question, and I really appreciate asking this question. Say suppose uh, you're talking about Gmail, or maybe say suppose Office 365, right? How do you isolate a customer data? And you're still having the cross-tenant insights. I'm talking from the developer's point of view, right? First of all, guys, to those who doesn't knows about multi-tenant, what is multi-tenant system is a single application instance server serves multiple customers. A customer is considered as a tenant, okay? Each tenant, each customer basically logically feels they have their own environment, but physically they share the infrastructure. In infrastructure comes everything: compute, storage, database, etc. Now, guys, there are three models which are very famous or which are very common these days in the case of the multi-tenant system. Number first is the shared database, shared schema. So all tenants would be sharing the same database and the same table. The tenant ID would be different. Basically, tenant ID is the one which would distinguish the data. Okay, this is the first model, and this is where I think the Gmail basically operates into. The second model is the shared databases and separate schema. Now, each tenant would get its own schema, means set of tables inside the same database. And third and the last model is the separate database per tenant. Meaning, the one that you were asking, each tenant gets its own database. Okay. I hope so far it is clear. These are the three models. So in the first model, both the companies, both the customers' data would live in the same database and same table. So while if you have to query, you would have to query the filter by the tenant ID. Now, coming to the second part of your question, how the data aggregation happens from one company to another. So guys, let's take Gmail as an example. Okay. Now imagine that user, every user is a tenant here, right? Because they have their isolated data, like they have their emails, attachments, etc. But Google would still aggregate it like in a global analytics fashion. So they would still have their common spam detection. So they would train their ML model on anonymized emails. If you talk about the storage trends, performance metrics, trends, etc., all of them, they would be running like a global analytics at the global layer. Now, how the aggregation happens? Of course, they would use like the metadata pipelines. They would only aggregate or anonymize the data flows to the analytics systems. They would use the tools like BigQuery, right? Or Kusto, for example, on the Azure to handle the cross-tenant aggregates, right? So that's how, guys, isolation and data aggregation basically happens in the real world scenarios. Does that answer your question? Or if you have any question, please ask.
It's clear now, sir.
Very good.
Sir, I do have one more question related to the same things. I have the application written in the C, and
Language?
written in the C language. It's application. Basically, we are running on the client based. We need to install it on the laptop and run that application. Suppose I want to make that application as a SaaS.
Oh,
And that application require license also. How are we going to handle the licensing portion in the SaaS model for that application?
so if I understand, you have a C application,
Yes.
C basically language, and your application needs to run on the client side. So basically, you need to install your application there, right?
Yes.
So now, what is your question about the
My
licenses?
question, like, I want to convert that application,
Oh,
SaaS based application, web based application, so that I can use this SaaS features and deploy that application in cloud.
huh.
But that application need license also. We need to run the license server to run that application.
I see. I see. So, so licensing requirement is for every customer.
Yes, for every customer.
Okay. So very good question, I think so. So I would answer your question in two parts. So the first part is this uh, thing about movement and migration. The second part is about the licensing.
Yes.
So see, your current model is written in your current application is basically written into the C language, which is installed locally on the customer machines, right? And you have your license keys, which is basically coming from a license server or whatever is that, right?
Yes.
Now, the first thing, in order to go cloud native, you have to decide amongst the choices that you would have. Choice number one, you would like to host your existing application as a service, for example, in the infrastructure as a service or a platform as a service. Or you would, second option that you have is you want to wrap your logic as the microservice or the cloud native one. So you have to refactor your code logic into the maybe say suppose some RESTful APIs or the things like that. Often you would find that the companies would basically choose from one of these two options and they would try to host their existing application as a service. So they would containerize their application first of all, and then they would basically deploy that as the, like, for example, software as a service backend. Okay.
Yeah.
So now you would introduce the multi-tenancy layer by using, like, for example, tenant ID or the customer ID concept. So every user's request would be scoped by their tenant. That's how you can do the transition from the client-based application to the cloud-native application. Okay.
Okay.
So basically, I summarize, you would have to run the compiled CLab binary into a virtual machine or a container, and you would have to expose it via the API or maybe through the web UI. Okay.
Okay.
Infrastructure as a service model. If you want to host it, then you can also host it via the Azure App Services, as we have seen the demo of it, or the AKS also. Now, after you have lifted and shifted your applications into the cloud and you have deployed your SaaS backend, you have deployed your infrastructure as a service backend, what you can do is you can use any option, for example, like Azure App Service or Azure Kubernetes Service to deploy the backend. Okay.
Okay.
And finally, as I mentioned, introduce the multi-tenancy layer by having the tenant ID concept into your database, which would ensure the isolation between the customers. So that is about the part number one, that is moving your application from the client based to the cloud based. Earlier, you used to give your application in the form of the binary to the clients and they need to install that. Now, you do not need to give any SDK to them. Rather, you are hosting them onto the cloud and exposing your services via the APIs. Of course, there would be authentication of these APIs that you'd have to manage, but this is the model that you would go into. Now coming to the second part, which is implementing the licensing. Now your licensing logics is per install based. You would have to change that to the cloud identity and metering kind of systems. You have many mechanisms there. For example, you can log your usage via the API calls or the compute time, right?
Mhm.
So that is kind of one billing usage monitoring based kind of thing. You can send your usage events to the event hub or maybe to any of the models that you would like to use. Right? So your application checks this on every API call, basically, that what would be the usage that you would have to record. So there can be many other models, but the metering one is one that that is coming to the top of my head that I explained. So rather than the install based licensing, you can have the per usage costing.
Okay.
Okay.
Yeah. Does cloud service provider provide any mechanisms to handle this metering things?
This is something that you'd have to build.
Mhm.
There are many options. You would have to build one. Of course, there is no out of the box uh, thing that I'm aware of, but something that you'd have to bring because usage can be customized, right? You'd have to
Yeah.
specify the model.
Yes.
You specify
Basically, it's a license is very much customizable. Someone just need one feature, someone need all features, someone need two features. The kind of things we need to customize in the license.
Mhm. Yes.
Okay. Thank you. This is the one challenge we are facing in our industry. We are thinking to move towards that direction.
Nice, good. Yeah, we can discuss more on this separately also.
Yeah.
Okay. Any other question, guys? All right. So let's move further if this is clear. So business model, if I can compare. So if we have to build an application for a specific customer, it needs to be designed for that customer so that it can be installed, managed, and maintained. But here in the case, it is all internet-based services which are provided in the case of the SaaS. Okay, here we architect the solutions in the traditional package, which is run by the individual company. Whereas here we have the applications which are designed for thousands of the customers, which using a single code base. Okay. And when it comes to the upgrade, generally in the traditional package software, you would get these major updates every 18 to 24 months as such. And these upgrades were charged, but in case the software as a service, this is not the case. These are all called as digestible upgrades, which comes every 3 to 6 months. And these are all fewer upgrades compared to the larger upgrades that we talked about. Okay. And here we used to have version control and upgrade fee, which will be charged. But in the SaaS, it does not look into any of these things. And in traditional packaged software, mostly all of these services were client server kind of thing, and certain things were over web as well. But when it comes to the SaaS, it is mainly over the web. Of course, you would have to make use of some API calls, as I was just explaining. So here you kind of understand, my dear students, that what are the hidden costs of the application which is built by a company to application which is consumed from a service. So here what is visibly is only 9 to 10% of the cost which corresponds to the software licenses, and rest 95% cost is still there, but it is like not visible into the hardware, IT personnel, right? Maintenance, training, and customization, etc. Whereas when it comes to the software as a service, yes, subscription fee is higher for implementation, higher, but implementation, customization, training is 32%. Of course, here also it makes up to 100%, but this 100% makes very cost effective as compared to this left side 100% for the client service architecture. So what we are trying to say here is hidden costs are more when it comes to the traditional model compared to the software as a solution. Okay. So guys, these are the advantages that we have already seen. So I'm going to skip this. These are the various data attributes which compares the SaaS and on-premises. These also we have discussed in the earlier details. So I'm going to skip this for you people to study yourself. Okay. Now we are going to see the benefits of the software as a service for user as well as vendor. For user, what kind of benefits we are looking at? There are no upfront costs. Okay, I don't have to go and purchase a huge amount of licenses as such. Basically, it is on the user subscription. So basically, depending upon how many users we would like to allow them to use this particular software, I can go and only subscribe to that as much. If I want to increase it, I can increase it on the fly. I don't have to really wait for the subscriptions or the licenses to come in my way. And software is available immediately as soon as we purchase it. Generally, what it used to happen earlier is first we used to purchase the license and then they used to deliver to us. And then we used to set it up and configure them. Only then it shall be available. Easily, it would take around 10 days or so for us, but now it is easily available to us. And with this, we can now focus on our core competences. That is what our application company has to do instead of looking into how can we save on the capital or how can we save on the efforts which would be on the setup of infrastructure or technology stack or get it IT personnel. So instead of looking into all of those things, we can focus on core competencies. Okay. Next is access anywhere. Compared to the traditional model, since it is over the internet, we can access it from anywhere. So I have my Gmail account, whether from here or from any part of the world, I should be able to go ahead and access my account. But the traditional model, it does not really allow me to do that until and unless you have your configuration. So freedom to choose is the next one. Traditional model generally would be tied up with the licenses which you have purchased, a number of years you have purchased for. But here in case of SaaS, it is not the case. Since you go with the pay-as-you-go nature of the SaaS, it enables us to try different softwares. And if we find something better, we can always move to it. Here subscriptions would be on a monthly basis and would not be on the annual basis. Well, in SaaS, we can also go on a yearly basis and cost would be further lesser. Okay. New application types. So here we have, because there is a barrier, right, to use a software for the first time, it may be feasible to develop the applications that may have occasional use cases. This would be impossible in the case of the perpetual license model, guys, because there is a high upfront cost and hence the number of participants would be much smaller in that case. So another benefit that we would like to have is the faster product cycle. Here the product releases are more frequent, which contains new features in a very less time compared to the upgrade which used to happen once in 6 months or since in a year. And the best part is that the bug fixes which happens almost every week. So this kind of helps for users to use the better product and use it for more productive ways rather than the previous models. Now, like SaaS, moving to the SaaS vendor benefits. Here, vendor can see the increased total available market. What is this increased total available market? So earlier, most of the vendors would be very locally present as such. Otherwise, they need to have their sales office and they have their salesperson in the different countries. I mean, basically, it was a scale problem. Now, since it is present over the internet and it is present for the subscription, you don't have to really have a local presence in each and every country where you would like to venture into. Enhanced competitive differentiation. Here, every product owner is forced to move to a SaaS model because it gives them the edge compared to the traditional models, right? Why? Because the SaaS applications would create opportunities for the new companies also to compete effectively with the large vendors, isn't it? Every model would change into a use case based model on the cloud, which can be accessed via the APIs. So therefore, it is evident that it is a double-edged sword, guys. It's evident that the software companies would have to have the pressure, would have to handle the pressure from their competitors to move to the SaaS model. So those who are really lagging behind will definitely find it difficult to catch up because the software industry would continue to evolve rapidly also. And then there are some lower development costs also. It is studied that there is a main saving of around 35% as such. Why? Because releases are very small and frequent. Since they are small and frequent changes, there is a less to test as well, right? Effective low cost marketing. This is again tied to the quicker time to the market. Earlier, the only way was to have your salesperson to go around the world and publicize the product and try to make it known to the people. But now it is available in just one internet search. Very recently, Bits subscribed to the Jira. Now you guys might be wondering that whether Bits into the software development. No. Bits subscribed to the Jira was to maintain the work processes in the Jira. And we didn't talk to any personnel of Atlassian for that matter. No one came and marketed for us. Nothing of that sort. We just put in a request. We wanted to have a demo. There was a demo organized. They showcased the benefits of it. We were happy with it and we went ahead with a subscription with a minimum of 20 people to see as in how it is to use to the Jira. Next is predictable MRR revenue. This is like monthly recurring revenue. Since it is purely on subscription basis, you definitely know for a fact that how many users have got subscribed, how much is your monthly expenses. And obviously you can see that it improves the customer relationship between the vendors and the customers. And protecting of the IPs is also not a problem these days because there are illegal copies which are available. Earlier you distribute the software and there shall be so many pirated copies which shall be available. But since now most of it is running in the vendor's place, there is no way for that someone can copy it as such. Let us now look into some of the scenarios as to look into whether this software can fit into SaaS or not. But before I proceed to the scenarios, guys, any questions in the benefits? Any questions anybody would like to discuss or think about? Okay, so if there are no doubts, let's proceed to the scenarios. So guys, this is a question to all of you first of all, okay? So please be ready. So guys, there is a single user software application, something like Microsoft Office Suite, which was there earlier, not the Office 365, which is available now over the internet. What are its attributes? Generally, it is used to organize personal information, and it runs on the local machine, and it serves only one user at a time. Okay. Do you want to see that as a SaaS model? Tell me,
No.
everyone. Please put your hands in the chat window, everybody. I want the participation from everyone. You're right. Everybody's right. Yes, very nice. Thank you. No, this is not a SaaS model, guys. Right? I hope everyone understands. Moving on. So you have infrastructure software like Office or Oracle database. So this is incapable of the SaaS model as the installation is required locally. Of course, we can move it as the cloud, but mostly it will be the part of infrastructure as a service, or it could be the part of the platform as a service also. Okay. Now we have embedded software. So here the firmware is perfectly embedded into the hardware device. So this is also applicable to the SaaS models. The software which is embedded in ATM or in the cell phones or the router, right? That is what it is being used over here. The enterprise software application, this is the one which is most standard type of software which is applicable to the SaaS model. So the applications like CRM, CRPs, learning management system, CMS, these are various applications which could fall into the category of the software as a solution. Okay. So with this, we come to the end of our current lecture. If there are any questions, then you can please ask for it. So if no doubts, guys, then let's discuss a bit about assignment. How is your assignments going on?
So regarding the assignment, I had a question. I'm sorry for bringing this up now because I mixed up last 1 or 2 classes around Diwali, but I'm not sure if you have mentioned this. So for this assignment, can we project for the first part of the assignment, which is the test bed for the case study? For that, can we project something from our company, which we are working on currently? For example, if we are working on a client migration requirement, so can we use that as a case study?
Yes, of course. The intention is that only to pick up some real-time use case. And if it is from your own company, then yeah, it is nothing like that, right?
Okay.
And sir, we can create people of two people, right? Group. Not necessary. We need to create for group of 5 people.
Sorry, you're
I'm
asking that.
asking.
Mhm.
Yes, I'm asking. Is it required to create group for 5 people only, or we can have it less, like 2 to 3 people? Because it is very difficult to collaborate with all the 5 people actually, because in the weekdays and all.
Sure. Go ahead with 3 people then. The intention of having five is just to have the coordination. But if you think that it is getting difficult, yeah, let's have three.
Okay, okay.
Yeah.
Regarding the second part of the assignment, which is regarding developing an application or a proof POC. Uh, so by application, what exactly is the expectation that is, means what is really the expectation that is set here? Means what is the complexity of the application, or means could you please shed some light on that? Means what kind of an application are you looking for? Or is there any some specificities around that complexity?
Yes, good question. So basically, in the second part, what you're supposedly to do is you're supposed to develop an application which can be any of your choice from end to end. You can pick up any use case from the world, which basically around the domain that you like, and you have to build everything from the scratch. For example, like you can build the home surveillance systems, right? So basically, there are some cameras which are sending some real-time data. Then that using that real-time data, you are basically using the IoT. You are doing some computations. You're doing some, uh, you know, some sort of analytics on the top of that, right? So stuff like this is something that you can basically think about out of the box. But do remember, it has to be hands-on. You have to really do something interesting to bring out some more interests to that.
And sir, do we need to present to you the working application end to end, or any session we
You
need to? Yeah.
see, the one that I earlier proposed is you have to record the demo and you have to send the same to my email address. That is how what we thought. But if you think that
Okay.
you have done something really remarkably which you're proud of, and if you think
Okay.
that hey, you would like to really, you know, want me to come on call, then of course we can schedule an ad hoc call and we all can come together to discuss that.
Okay. Okay. Understood. And one kind of document need to be prepared, right? What that application is all about, architecture, and why we are using these service, and the detail about the application that we are building, right?
Of
That kind of.
Yes, exactly. So that is a detailed report. That is the detailed
Oh,
report you have to prepare for that.
submit. Okay, okay, okay.
Yes.
So I have one
And
quick question. Sorry,
yeah,
sir.
sorry. Sorry, last thing. So we are free to build our application using Azure and AWS or GCP, right?
Whatever.
Anything
Yes.
and whatever. Okay. Okay, thank you. Please go ahead.
Sir, one quick question regarding the assignment 2 is that we have to develop an application and show it in the demo, right? So at that time, all the services for the application development, suppose in general scenarios, we use the GitHub, but that we can achieve through the Azure DevOps, right? So
Right.
every services we used will be a cloud service or any third party is also okay.
See, if it is on the cloud, then it is okay to use.
Okay.
Yeah. At the end of the day,
Even
it
if
has
it is even if it is a third party, it won't be a problem. It won't be a problem, right?
Yeah. Can you give an example when you say third party? Any third party?
Yeah. Suppose we are developing the Netflix application, so we would like to store code in the GitHub as a source code, version control. So from there itself, we are fetching and deploy it in the EKS cluster. And for that one, we have used the Terraform for our infrastructure provisioning. So
Sure.
like that, we can develop.
Yes, yes, of course, yes. That sounds great. Yes, you can do that.
Okay, thank you.
Okay.
We develop an application or something, and later we containerize it with Kubernetes, and then put it on cloud, like a cloud or Google Kubernetes engine zonal cluster, like that. Is it also fine?
Sorry, you're breaking for me. Can you repeat again?
Yeah. If we develop something, we use Kubernetes for containerizing it, and then we place it on cloud. Is it fine?
But yeah, you place it on the cloud using AKS. That is fine. Containerize it, but but make sure that you're well able to access that application also. If the application is inaccessible, then it would be difficult. Yeah.
Got it. Okay.
Sir, one more question regarding the POC part of the assignment. Even if you do a POC, that also needs a working demo, right? So we need to build a small version, hands-on working stuff over that as well.
Sorry, what thing? Sorry, which thing?
Regarding the POC, means if we do a POC, that also means that we have to do something. That means we have to do kind of build a working application for that as well. Right?
Right.
So it can
It has
be any you. Yeah.
Go ahead, please.
Yeah, I was saying, sir, it can be any use case that is currently out of the existing. We can pick up that use case and build on top of. Build on that, right?
Yes. Any use case is fine, as I mentioned, but please do mention your use case in the Excel sheet because that is very important. Until you don't mention, then we cannot know what you are doing and what you are developing. So no surprises, and you can connect to me and we can discuss that.
Sir, our main maintenance developing the application that is hosting on cloud-based environment. So, what is the main method of this assignment?
Sorry, I could not hear that. Could not understand it well. Can you please repeat?
I'm audible, sir.
Yes.
Yeah. So, our part two assignment main method is developing app new application like that, or it is like hosting the whatever application on the cloud-based platform and utilizing the maximum services that offer the cloud, like the monitoring of the cloud, or monitoring of these applications, or real-time like analysis of the application, like based on the throughput, congestion, and latency. It means maximum task is for the hosting part or for the development part. There will be a question.
See, your observability, your monitoring is fine, real-time monitoring is fine, but if you're building such an application, then you have to have some supporting parent application. Observability can be sidecar. It cannot be the full-fledged front end, right? Because you already have the services for that into the cloud. So whatever you're doing, you would have to choose that very, very legitly so that you can showcase the full use case for that, including the observability and monitoring also. Is it clear?
Yeah, but the basics are like so. Developing the new application takes so much of time. So instead of that, we can take any application which is available on.
No. What do you mean by a lot of application? Of course, it will take a lot of application, so a lot of time. You have to develop that. You cannot bake that into an existing application. No, that is not allowed.
Okay, and I'm thinking that taking up this from any application and modifying it to some level and utilize the maximum cloud services, putting the application behind the container, like microservice architecture we are doing, and like hosting a URL on the cloud side or GoDaddy, like all the things will be doing the flow. So maximum thing will be hosting part rather than something else. Is my understanding right, or can how to do well structure application and start working on it?
Yes, you're right. Yes, you're right. Whatever you are building, you should host it into the cloud and you should have it on the cloud. You're right. Okay.
Okay.
Cool. Any other question, guys? Any other thing that you would like to discuss?
So we need to submit by 15th November. Is that right?
That is what you guys have asked for, right?
I think someone from the
The date was 30th October, but yeah, since you guys have requested for the extension, so I think that it should be fine.
okay. Thank you.
Okay. Okay. Any other question, guys? All right, then. If there are no questions, then thank you, everyone. I hope. Okay, there is a question in the chat window that I can see from the Sanjay, Tushar, Can we do 2 topics on case study, one from one computer? No, I think one is fine, but yeah, you can do, but the marks are going to be limited only for one, right? So rather you spend that time, invest that energy into the part number 2. That would be my suggestion. Of course, you are free to do whatever you like to do. But there's only one use case that you would have to present that.
Thank you, sir.
All right. Thank you, everybody. Then see you soon. And so there is the first part of the assignment, individuals one. No, every part is a group one. You have to do that in the group, right? Nothing has to be done in individual. Okay. All right.
Sir, last question. Sorry, sir. So, basically, like I am still confusing me. The assignment, how will be its real-time application? So far, for we are creating assignment based on one application where we are just fetching the data and storing in the container. Basically, it will run inside the containers. So there is no much functionality or complexity. Just we are fetching the data from S3 and database and running in the container, and like we are using some ECR, EST and all. So is it fine, or do we need to make some more real time application kind of?
Yeah, I think you should make something more interesting and complex. No, just creating a simple application may not really be very,
Okay.
very expected, very good. Something go for a big thing, guys. Right? Go for a big thing.
Okay.
Okay. Thank you. And see you soon. Bye bye.